This will be a brief description of a program that automates the design, analysis, and drafting of shear walls and columns that I wrote for a structural engineering company in Costa Rica. It's fairly complicated with too many features to cover in a short video, so I'll provide a basic overview here and create a part 2 that will cover features more in depth. This very nice structural engineering company had these spreadsheets here that they created years ago with which they analyzed and designed individual shear walls and columns. It was the only tool that they had for shear wall and column design that would be sure to comply with the unique and rather complex seismic code here in Costa Rica. But the problems were that it was not easy to use. It was numbingly repetitive because each shear wall and column had 10 to 25 design datums, and there could be 3,000 to 6,000 or more shear walls and columns in a large project. And there could be many design revisions, which meant that these spreadsheets could need to be used thousands of times for a big project, taking weeks or months, or having to hire more employees just to manipulate these spreadsheets. And that could lead to human error and serious design problems and liability. Also, they had no good way to store the final design. They just printed out the spreadsheet each time they designed an individual shear wall or columns. It was just terrible. The main features of this program is a 99% reduction of design time, elimination of human error. It turns a mind-numbing task into a pleasant experience, and it automates the production of design documentation. And it also automates the drafting of the shear walls and columns in AutoCAD from inside the design and analysis program. The program does what a human would do to use the spreadsheets. It enters all the engineering data inputs into the cells and then interprets and displays the analysis results from various output cells, which previously required a human to interpret using various unwritten rules, like comparing two different output cells or looking at a graph to see if various internal force states appeared within an area on a flexocompression diagram, or if a particular cell was above a certain value. The program does this automatically and clearly displays the results of the analyses and whether individual tests required for code compliance pass or fail instantaneously upon any change in the engineering data, and allows the user to change any engineering data from the dialog where it is clearly organized. There are interfaces for changing the engineering data defined in the groups as well as the element memberships in these groups. And when group data is changed, every element in that group is automatically reanalyzed. When the design work is done, the program connects to Microsoft Access and creates custom reports for all the elements that look great, and the program connects to AutoCAD to automate the drafting of the structural elements, which can be drawn all at once at the touch of a button or can be inserted individually. Okay, without further ado, after that long description, here's the program. This is the shear wall module of the program. On the top, there is a list box with a line for every shear wall in the project. And this information here is the length and the width. And there's also the height in there somewhere. They actually had me remove it because they felt it was superfluous. All the heights are the same for most of the project. And over here, this blank area is where all the engineering data is going to go, which is the product of this program. And over here are engineering tests to see if the shear wall will comply with the seismic code. And you fill in this engineering data in one of two methods, and that is manually by entering it in individually here, or with engineering groups, engineering data groups, which will allow you to assign all the data or assign part of the data for individual shear walls at one time. This right here is overrides. That's what valores modificados means in English. It means overrides. And this here are the what do you call it? Effective values. Okay, you can always override any of these groups with by entering in data here. So let's choose these 4 groups here were engineering data groups that the company wanted me to have pre-assigned, so you didn't have to create these groups each time you did a project. And I'll show you these groups now. That means edit the groups, and you can highlight a group here, and you can add, edit, or eliminate groups. You can change the names of groups. Right here, I'm going to edit so you can see what's involved. This is basically just a copy of this region of the program, and it allows you to create engineering data groups. You can define it all, like is done here with this group, or you can partially define it and have more than one group defining data. I made it as flexible as possible. And you can copy another group to create a new one. Predeterminados means defaults. There's one default set of data that you can get just by clicking this button, just like that. Now there's the default group data. I'm not going to keep these changes. I'll undo it. But anyhow, that's how you manipulate the group data. I'll click OK, and now I can define all of that. I can define this shear wall to be in this group just by clicking like that. And it figures out what the effective values are, and then it runs the tests, and it shows the results of the test here. And as you can see, all these tests comply. So the overall test complies as well. This is a very simple building. It doesn't have many floors, so it's very easy to get these shear wall elements into compliance because they're not under much load. But once you're happy with a particular design, you can save the changes of this element into memory. When you click this, all this information gets recorded here, including the status. And as you can see, complete means pass. So then we can go on to the next one, and we can do the same thing. But an easier way to do this would be just to assign many of these shear walls into one of these groups at once. You can do that with a shear wall group membership dialog. And here I will highlight group M30-1, and then I'll highlight these shear walls here. And then I'll click the button that says add elements to the group. It asks me if I'm sure. Yes, I'm sure. And as you can see, it is defined all these elements as members of group M31, and it also shows you the data that is defined in the group. And there's no results yet because it's going to wait until I press the OK button to retest all the elements whose data has changed. And here we go. So it's going through all the shear walls. It only went through a part of them because only a part of them had their data changed. And as you can see, they're all passing. I'll have to make one not pass so you can see what's going on here. Maybe this one won't pass if I put it in a weaker engineering data group. This is less steel inside of. There we go. This one doesn't pass because, the quantity of screens is not sufficient. So what I can do here, you see this Mayas thing? That Mayas is number of screens in Spanish. And the screen is basically the steel that runs through the shear wall. You can have one screen in the middle, which is just vertical and horizontal rebar. Or you can have two. And here, this will allow you to override the groups. Now we got two here, we got two here, and sure enough, quantity of screens now passes. So now we can say, save these changes into memory, and as you can see, it's here. And this is good because M15-1 has less steel in it than M30-1. And since it still complies, you've saved some money in steel. And let's see, what other features can I show you about it? Here, oh, there's plenty more to go. For example, if the engineers need to take a look at the shear wall to see what's going on, because that's what this program is based on, you can click here, minimize screen it says, and then you got this very small little dialog, and it'll allow you to see the shear wall spreadsheet being updated dynamically. I'll choose another shear wall element, and you can see all the data changes. You see that? Isn't that nice? You can see the program in action manipulating the spreadsheet by changing all the data and allowing the spreadsheet to do its thing to reanalyze it. And then you can go back to the large dialog. And suppose you're pretty damn happy with the design here, and you'd like to insert a block of this into AutoCAD. All you got to do is come down here and click this button. And sure enough, take a look at that. There's the shear wall in AutoCAD with dimensions and annotations. How's that? And then we'll go back to the program, and I forgot to mention this. You can see an image of the shear wall. It's generated in AutoCAD, and then it's thrown up onto the dialog here. And that is a picture of the border element, and you can also see the entire wall. Thusly, we'll go back to the border element view, and for example, to show this changing dynamically, I'll change this steel here. I'll make it larger, and I'll put in 4 bars instead of 3. And that is right here. This is the external layer of the border element. Instead of 3 number 5s, I'll put in 4 number 7s, 4 number 8s, 4 number 8. So now it's going to recalculate. It passed the test. Now it's going to draw the picture. And sure enough, take a look. That vertical steel is larger, and there is 4 of them now. And let's see, what else is important to say about this program? Over here are the internal force states of this particular shear wall. And over here is a list of shear wall elements that do not comply with the code or have not been tested. And oh, of course, listen, I mean, imagine, you're all done here. You need to make documentation. The documentation can be generated automatically just by pressing this button here. So it's going through all the data, doing analysis on each one, and then is going to create a beautiful report in Microsoft Access. And there it is. And so this is the front page. They asked me to create an index by level. And then the rest of the report is the individual shear wall elements with the engineering data, with the internal forces, and then the analysis. And there's one of these for every element. And as you can see, we've reached an area where the data was incomplete because we had not defined it, and it says that if the data is incomplete. And you can take this, you can print it, and then when you're done, you can go back to the program and continue on. And all right, so that is a brief explanation of the shear wall analysis and design program dialog. And I did a similar one for columns. Same methodology, it's just that the engineering is different. In columns, there are 2 flexo compression tests, one for the X direction and one for the Y direction. And there's also a percentage of steel in the column test as well. Those are the only 3 tests required. And that's about it, I think. I'm going to wrap up now. All right, well, I want to thank you all very much for staying to the end of the video, and thanks so much for watching. Have a great night.